This is Math Analysis, Pre-Calculus, Section 7.4, Part 2 of our notes on partial fractions. That is the question where we left off. Finding partial fraction decompositions of improper fractions. Alright, so now there's another type of problem here. If the denominator of the fraction has a repeated linear factor n times, then you need to include an extra constant for each power from 1 to n. Let's write out a couple of examples here. The first one, suppose I wanted to write the decomposition of 1 over x cubed. I would have to write a over x plus b over x squared plus c over x cubed. So 3 different variables I'd have to find there. Another one, let's have x plus 3 over, say, x times x plus 2 squared. The partial fraction decomposition of this would need to include 3 constants. A, b over 1 of the x plus 2's, and then c over the quantity x plus 2 squared. These can get pretty big, so at this point you can consider using matrices in order to solve the system. Denominators with multiplicity. By the way, repeated factors. Okay, we're going to say that's the same thing as multiplicity. Find the partial fraction decomposition of 4x to the third plus x squared minus 10x plus 4, and then we're changing the denominator here to x to the fourth minus 2x to the third plus x squared. First of all, this is not an improper fraction because I have the highest degree of the numerator is less than that of the denominator. So we're okay there. That means I'm just going to factor as much as I can. I'll take out an x squared, and that leaves me with x squared minus 2x plus 1. And that thing right there is going to factor into x minus 1 squared. So let me rewrite this problem into 4x to the third plus x squared minus 10x plus 4 over x squared x minus 1 quantity squared. This should equal a over x plus b over x squared plus c over x minus 1, and then one more, plus d over x minus 1 squared. My first step, factor the denominator. Okay, all this is going to get smaller. Next, let's make a common denominator. So see if you can follow me on this. For a, I'm going to have to multiply the top and bottom by x and by x minus 1 squared. So a times x minus 1 squared. That's going to be ax, and then we'll expand that out. Distribute the ax to the third minus 2ax squared plus ax. I'm going to have to do the same thing with b, but in order to make a common denominator here, I would have to multiply the b fraction only by x minus 1 squared on the top and bottom. So for the b, I'm going to get bx squared minus 2bx plus b. Keep doing the same thing. So for c, I can multiply the top and bottom by x squared and x minus 1. All right, and then finally the d, all I have to multiply is x squared. So that's going to be dx squared. There is a lot going on here, but I can now take all 4 of these expanded pieces and equal it to the numerator. A lot of terms. All right, now let's put them in some sort of order by degree so I can match up these coefficients here. So now this has got to be equal to ax to the third. All I'm going to do is rewrite it. Plus cx to the third. Cross those out as you go. Minus 2a x squared plus bx squared minus cx squared plus dx squared. Plus ax minus 2bx plus b. All of that matches up with the numerator. Okay, now from there, look at your cubics. Factor out an x to the third, so it must be true that a plus c equals 4. Next one. This is 4 things here. So if you factor out an x squared out of all of those, it must be true that negative 2a plus b minus c plus d equals 1. That's the coefficient of the x squared. Next, a minus 2b must equal negative 10. And then the last one is really helpful. B must equal to 4. Now here is a system of 4 equations and 4 unknowns. That's kind of why I spaced them out, because I can then use my matrix algebra, or I can just use regular algebra. If you were to solve that system, you would get answers of b equals 4, a equals -2, c equals 6, and d equals -1. After all of that work, we can now write the partial fraction decomposition as a, which is -2 over x, plus b, which is 4 over x squared, plus 6 over x minus 1, plus -1 over x minus 1 quantity squared. That is my final answer. Okay, recall that those partial fractions come from the very first step where we factored the denominator. All right, there you are. Denominators with multiplicity. Please comment on this video in order to earn credit, and then have a nice day.